Lesson 5.1, Solving Inequalities by Addition and Subtraction. Essential question, how do you graph an inequality? The vocab word for this lesson is inequality symbols. Inequality symbols are something that you should be familiar with. Once I write them down, I think that you'll recognize them. They are greater than, less than, greater than or equal to, and less than or equal to. So we're going to work with problems in this lesson where instead of an equal sign, we have an inequality symbol. On the next page, we'll go into more detail about what each of those inequality symbols means. How do you graph an inequality? How do you determine if you use an open or closed circle on your graph? And how do you determine which direction the ray is going? So first of all, we have to figure out if we're going to graph this, what kind of circle we're going to use. Less than or equal to and greater than or equal to both have a closed circle because the or equal to means you include that point or that number. And less than or greater than symbol have an open circle. It means that number line does not include that number. So for example, if I have x is greater than 5, if I put that on a number line, I always put the 5 in the middle and I like to do one number smaller and one number bigger on both sides. The greater than symbol, if you look over here, means that I'm going to have an open circle on 5, and then I have to think about if x is greater than 5, what numbers could x be? Well, what numbers are bigger than 5? 6, 7, 8, 9, and so on. So that means I'm going to shade to the right. Every single number to the right or that's bigger than 5 is a solution to this inequality. This is different than in the past where we had an equal sign because we had just one right answer. We'd have, for example, x equals 5. So that means x had to be 5. With inequalities, we have tons of numbers for our solutions. For this example, any number bigger than 5 is our answer. We'll get more into this in the next problem. The next part in this question says, how do you determine which direction the ray is going? Well, you have a couple possibilities. Like I said, we listed out numbers that were greater than 5. That's one way to figure out which way your ray is going. Another trick is if your variable is on the left, you can think of the inequality sign as an arrow. This arrow is pointing to the right, so I shade it to the right. So if I turn my inequality sign into an arrow, I would shade to the right. If mine is less than, I can turn that into an arrow and shade to the left. This only works if your variable is on the left. If your variable is on the right, it wouldn't work. All right, so let's practice graphing some inequalities. First one is x is greater than -2. So the first thing I have to figure out is what kind of circle I need. Well, I know greater than and less than have an open circle, so I'm going to put an open circle on -2. Then I've got to figure out which way to shade. Well, I could do two things. X is greater than -2, so I have to ask myself what numbers are bigger than -2? -1, 0, 1, 2, and so on. So that means I'm shading to the right. Those numbers that I just listed are to the right of my circle. The reason why -2 is open is because -2 isn't greater than -2. So that number, this right here, is not included in my solution set. And the answers start with -1, 0, 1, 2, 3, and so on. I can also use my little trick because my variable's on the left of making this into an arrow. My arrow is pointing to the right, and that's which way I shade it. The next one, x is greater than or equal to 4. Greater than or equal to means a closed circle. So then if I ask myself, what numbers are greater than or equal to 4? Well, 4 is equal to 4, and then numbers that are greater than would be 5, 6, 7, and so on. So those numbers fall to the right of my dot, so I'm going to shade to the right on my number line. I could also use my trick, since the variable's on the left, of turning this inequality into an arrow. My arrow is pointing to the right. X is less than 1, so put an open circle on 1. Numbers that are less than 1 or smaller than 1 are 0, -1, -2, and so on. Those numbers are all to the left of -1. Remember, 1 is not one of my solutions because 1 isn't smaller than 1, it's equal to 1. I could also turn my inequality sign into an arrow. My arrow is pointing to the left. That is the direction I shaded. X is less than or equal to -3. Put a closed circle on -3. Numbers that are less than or equal to -3 would be -3. And then numbers smaller than -3 would be -4, -5, -6, and so on. So those numbers fall to the left of my number line. I could also turn my inequality sign into an arrow. My arrow is pointing to the left. Now you're going to practice graphing with the graphing practice worksheet. If you do not have a copy of this, grab one from your math teacher. Now we're going to get into solving and graphing. So we're going to add an extra step onto what we were just doing. Inequality problems are just like equations in that we're going to start with our train tracks. But rather than putting our train tracks through our equal sign, we're going to put them through our inequality sign. Now we're going way back to one-step equations, which is what we did in lesson 2-2. So if I need to get x by itself, I have to think about how do I get rid of the -2. The opposite of -2 is +2. So I'm going to add 2 on both sides. These will cancel, bring down the x. Don't get in the habit of writing an equal sign. We now have to write our inequality, which was less than. 3 + 2 is 5. So there is my answer. Now I'm going to graph that. I'm going to put an open circle on 5. And then I could either ask myself what numbers are less than 5. So 4, 3, 2, 1. Or I could turn this into an arrow. My arrow is pointing to the left, so I will shade to the left. Again, another reminder that only works if your variable's on the left. Next one, I'll draw my train tracks. I'm trying to get x by itself. The opposite of +11 is -11. These will make 0. Bring down the x. Bring down my inequality sign. 7 - 11 is -4. Closed circle on -4. Numbers that are greater than or equal to -4 would be -3, -2, -1. I could also turn my inequality symbol into an arrow. My arrow is pointing to the right. Train tracks. X -3, if I'm trying to get x by itself, I need to add 3 to both sides. -2 + 3 is 1. Now you'll notice that our x is on the right-hand side instead of the left. This is the first time we've had one that looks like this. This part can be a little bit tricky when you're rewriting. I always rewrite it so that the variable's on the left so that I can use that graphing trick. That graphing trick makes graphing very easy, but you have to practice rewriting it because it can be challenging. Now I always think about which way is my Pac-Man mouth opening up. It kind of looks like a Pac-Man symbol. The Pac-Man mouth is eating or opening up to the X, so it needs to eat or open up to the X. Now I'm ready to graph. Greater than is an open circle on 1. If I turn this into an arrow, my arrow is shading to the right. Numbers that are bigger than 1, X is greater than 1, so bigger than 1 would be 2, 3, 4, 5, and so on. Next one, I'll draw my train tracks. To get x by itself, I need to add 8 to both sides because of that negative sign right there. Bring down my inequality symbol. 8 plus 1 is 9. My variable's on the left, so I want to get it on the right in order to be able to use my graphing trick. The Pac-Man mouth is eating the 9, so the Pac-Man mouth has to eat the 9. So that means I need a closed circle on 9, so I'm going to have to add a few dots here. 6, 7, 8, 9. So closed circle on 9, and my arrow is pointing to the left. Numbers that are less than or equal to 9 would be 9, 8, 7, 6, 5, and so on. Now I've got a variable on both sides. Draw my train track. If I have a variable on both sides, my first step is always going to be to get them on the same side. So I'm going to circle my couples, 3x and 4x. I could subtract 3x on both sides, or I could subtract 4x on both sides. I want to avoid a negative, so I'm going to subtract 3x. This should also be reviewed from chapter 2. Those make 0. Bring down the 1. Bring down the less than. 4 minus 3 is 1x or just x. Now before I graph it, you'll notice I have the x on the right, so I have to move it to the left. My Pac-Man mouth is opening up or eating the x, so it needs to eat the x. Open circle on positive 1. If I turn my inequality symbol into an arrow, I'm shading to the right. X is greater than 1. Numbers that are greater than 1 would be 2, 3, 4, 5, 6, and so on. Train tracks. Couple on both sides, so I'm going to circle my couples. To get rid of, or bring one over to the other side, I'm going to subtract 4x on both sides to keep it positive. Bring down the negative 2. 5 minus 4 is 1. This time I've got my variable on the left already, so I don't need to rewrite it. Close circle on negative 2. X is greater than or equal to negative 2, so numbers that are bigger than or equal to negative 2. And my arrow is shading to the right, so I'm going to shade to the right. Train tracks. Circle my couples. In order to avoid a negative, I'm going to subtract 3x on both sides. 9x minus 3x is 6x. Now this time I've got one more step. My variable still isn't alone. Remember, this is 6 times x. The opposite of timesing is dividing. These make 1. Now my variable's on the left, so I'm going to rewrite it. I'm running out of space, so I'm going to move over here. My Pac-Man mouth is opening up to the x, so I need my Pac-Man mouth to open up to the x. Open circle on 1. The arrow is pointing to the right, so I'm going to shade to the right. Variable on both sides, 12x, 13x. In order to avoid a negative, I'm going to subtract 12x on both sides. Bring down the negative 4, don't lose that negative. 13 minus 12 is 1x or x. My x is on the right, so I'm going to rewrite it so it's on the left. My Pac-Man mouth is opening or eating the negative 4, so it needs to eat the negative 4. Less than or equal to negative 4 is a closed circle. My arrow is pointing to the left, so I'm going to shade to the left. Summary. Your homework for this lesson can be found if you look at the MS Chapter 5 calendar. You can find the homework assignment there.